Hi everyone. In this video, I'm going to go over a problem related to energy conservation, but specifically one that involves internal or thermal energy. Usually when I think about internal or thermal energy, it's related to friction. So I'm thinking about an object maybe sliding up or down a ramp, or sliding or being dragged to the side across a horizontal table, something like that. In the problem we're going to do today, it's actually something falling. So there's still technically friction, it's just friction with the air. So it's a lot less. And you'll see that the numbers we use today are going to be a lot smaller than usual. So this is a physics Regents question from 2014. It's question 42. It says, a 25-gram paper cup falls from rest off the edge of a tabletop 0.90 meters above the floor. If the cup has 0.20 joules of kinetic energy when it hits the floor, what is the total amount of energy converted into internal thermal energy during the cup's fall? I started by circling my numbers and units, but I immediately noticed that 25 grams is not the SI unit for mass, so I needed to convert that. To get from grams to kilograms, I just divided by 1,000, and I wrote my new number right above that, 0.025 kilograms. So I'm not going to use the grams, I'm going to use the kilograms. The next thing that I did was I boxed some of the words that I thought were important. When it says from rest, that reminds me that it's originally not moving. So that helps me figure out that there's no kinetic energy in the beginning of the problem. From always means initial or beginning. And rest just tells me that the object is not moving, so that shows me there's no kinetic energy in the beginning. I put a box around above because that shows me something about the height. Since there is originally a height of this object, that means that it originally does have gravitational potential energy. And then I put a box around kinetic energy because that's what they're telling me with this 0.20 joules, and that I think that will be useful. They're asking me to calculate the internal or thermal energy. So I want to start by filling out this chart. Originally, it's gravitational potential energy, and that's just because it tells us how high above the floor it is. 0.90 meters above the floor means that there's a certain height for this object. I already mentioned why I know there's no kinetic energy. I also know that it's not elastic energy in the beginning of the problem or in the end of the problem because they don't talk about a spring or something that stretches or compresses. So I can definitely ignore this for this problem. And they didn't mention work or a force or a distance, so that's also something I can ignore. When I look at the final energy, there's two different types. There's kinetic energy. They told me that if the cup has 0.20 joules of kinetic energy when it hits the floor. So that helps me realize that the final energy is kinetic. Then they talk about internal or thermal energy. That is the same thing as waste heat. So there's a couple of different names for waste heat. You can call it internal energy. You can call it thermal energy. They all mean the same thing. So those are my two types of final energy. Normally what I like to do here is then fill in the amount of joules for initial and final, but that was not given to me. The only thing they gave me was the amount of joules for kinetic energy, so I'm just filling that in here to the side. It's not the total number for final energy, because I still don't know how much waste heat there is. So I can't really fill in these blanks yet. The way I'm going to try to fill in the blanks is by just calculating gravitational potential energy, because I think that they did give me enough information to use a formula to calculate that. So delta PE is my question mark. There's only one formula for gravitational potential energy, so I'm jumping right to this. Delta PE equals mg delta H. I'm using the kilograms for mass, not the grams that they gave me. G is always 9.81 meters per second squared, and delta H in this case is 0.90 meters. I'm keeping all of my numbers positive because energy is always positive. It's a scalar. So even though some of these, you could argue for a negative number for some of these, I'm just keeping everything positive. When I go ahead and plug this into the formula, I multiply them all together and I get 0.22 joules. Now that's not my answer, but it's going to help me get my answer because I'm going to put that into this chart. My initial energy is 0.22 joules because that is the amount of gravitational potential energy that I just calculated. The point of this chart is that initial and final energies are always the same. So 0.22 joules for the final energy as well. And basically what I'm looking at here is a total amount of 0.22 joules, 0.20 joules of those are kinetic energy, basically how much left over was converted into waste heat. To get my answer, if it's not already obvious to you, to get my answer I can just subtract these two numbers. 0.22 minus 0.20, and that's just the total amount minus the kinetic would leave my answer of waste heat, or as they're calling it in this problem, internal or thermal energy, and I get 0.02 joules, so that's my answer.